So this section is on trigonometric identities. First, let's define what a trigonometric identity is. It's an equality using trigonometry that holds true for any values of the variables. So let's first go through the basic trigonometric identities that relate sine, cosine, and tangent to cosecant, secant, and cotangent. And you should probably memorize these. We don't need to prove these because these are the definitions of cosecant, secant, and cotangent. And we can see that if these hold true, then there's three other identities that also must be true. These identities, you can basically solve for each other by, if you want to get from this one to this one, you can multiply by sine x and divide by cosecant of x on both sides. And because of the definition of tangent, which is sine over cosine, this can also be written as cosine x over sine x, and this can be written as sine x over cosine x. So here, let's just go through an example of how you would do a problem with these identities. So let's say you have to verify that this more complex identity holds true for all values of x. Okay, so to verify this identity, what we can do first is this side, we can multiply these together and get sine x over cosine x. And on this side, we can get this as sine x over cosine x times, wait, I messed up when writing the problem, sorry. This was not supposed to be 1 over tangent x, it's supposed to be cotangent of x. And this is going to be tangent of x, according to this identity, is sine x over cosine of x. And cotangent of x is, according to this identity, is cosine x over sine x. And what we can do now is we can try to see if these two sides are the same. If we can show that they're the same, then the identity is verified. So multiply this, and these cancel out, and we're left with tan x, because sine over cos is tan, equals tan x. So we have verified this identity. So there's a couple more identities that we have to know. One of these types of identities are called the Pythagorean identities, and the Pythagorean identities are that sine squared x plus cosine squared x equals 1, no matter what x is. And so the way you can get this identity, we can prove it actually, is if you have a right triangle, this is r, theta, x, y, and so because of what we learned in the SOHCAHTOA chapter by the definition of sine and cosine. Sine theta equals y over r, and cosine theta equals x over r. And then according to the Pythagorean theorem, x squared plus y squared equals r squared. And in this, what we got from the Pythagorean theorem, we can divide by r squared on both sides, and get x squared over r squared plus y squared over r squared equals 1. And then we can, using this, we can substitute in sine and cos because they equal y over r and x over r. And that comes out to be sine squared theta plus cosine squared theta equals 1. And that's the original identity, so we've proven it. There's two other forms you can write this identity in, just to make it easier to use in a lot of situations. So, to get the other two identities, you have to divide this original identity by sine squared theta and cosine squared theta. So, when we divide this, divide both sides by sine squared theta, sine squared theta, we get secant squared theta on this side, and 1 plus cotangent squared theta here. And if we divide what we had, cos squared theta, divide both sides by cosine squared theta, we get 1 plus tangent squared theta equals secant squared theta. And that's the other form of the identity. That's the other form of the identity. Another type of trigonometric identity that you have to know is the sum and difference identities, which are sine alpha plus beta equals sine alpha times cosine beta plus cosine alpha sine beta, and sine, so sine alpha minus beta equals, so to find this one, we can basically use sine alpha plus beta, except treat it as if it's sine alpha plus negative beta. So when we do that, we'll get that sine alpha times cosine beta minus cosine alpha times sine beta. And then there's also identities for cosine, sum of cosine, and sum of tan, and the differences of both those two. So cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. And we can do the same thing to get the difference identity, basically just substitute in minus beta for beta here, and we'll get cosine alpha cosine beta plus sine alpha sine beta. And then lastly we have the tangent, ones for tangent. So alpha plus beta equals tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. And then we have the subtraction 1 for tangent. I'm just going to give myself a little room here. tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. So here you see I also just substitute in negative beta for beta in the original one. We don't really need to prove this. We don't really need to know that, how to prove it. So let's just do an example problem. So let's say they ask you, what is cosine of 255, without using a calculator, find the exact value. So the way we can do this is we can break up 255 into 300 minus 45. 300 minus 45 is equal to 255. And we can use the subtraction identity for cosine. And if we use that identity, we get that cosine 300 times cosine 45 plus sine 300 plus sine 45. And when we start simplifying that, we can simplify this back to cosine 255. That, once we simplify this, we'll get, this is 1/2 times root 2 over 2 plus